Hi students, we're going to cover representing functions as graphs, which really just means plotting a few points. So it should be a pretty straightforward section. We do have our test next Wednesday. So if you have any questions, today would be a great day to ask them. Otherwise, we will have our test on Wednesday. I will post kind of study guide where you can just check off boxes as you go through the right section. Okay, so we're gonna look through this. So as you can see, we have a table of inputs and outputs, and they become ordered pairs. So our first point is going to be our input, our first before the comma, and then our second is going to be our output. Okay, now this is called an ordered pair because the order will stay the same regardless. So this is input and output. So notice we do points 1, 2, 2, 3, and 4, 5. So if we're plotting this on a graph, one, two, three, four, 1, 2, 3, 4. Notice we choose our x coordinate 1 and our y coordinate 2, our x coordinate 2 and our y coordinate 3, and finally our x coordinate 4 and our y coordinate 5. Okay, so that should be it. If you have any questions on how to get that, no, we'll continue on. Let's look at examples. So example 1 is going to look at a graph the function y equals 1/2 x with domain 0, 2, 4, 6, and 8. So in this case, all we are doing is step 1, have our x and our y. Now our x is our input, you do not need to write that. We go 0, 2, 4, 6, and 8. Now, and then we just plug this into the function y equals 1/2 x. Okay, y equals 1/2 x. So plug in 0, we should get 0. Plug in 2, we get 1. Plug in 4, we get 2. Plug in 6, we get 3. Plug in 8, we get 4. Okay, so that's our simple table. And then once you have your table, you're going to plot it on the xy coordinate plane. Okay, we will cover xy coordinate planes more in detail as we go. So let's go 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Can't read this. This is just going up by ones. 1, 2, 3, 4. So let's go 2 goes up 1, 0, 2 goes up 1, 4 goes up to 2, 6 goes up to 3, and 8 goes up to 4. And roughly speaking, this should be kind of plotted along the line. Okay, it's not that it has to be exact, but it should be. So you guys can practice, gotta practice right there. It's okay if you don't, because we're gonna move on. Now, graphing a function, they give us the scores, the SAT scores, and the years since 1997. So you notice average score slowly going up. Now this was back in the past. It has definitely changed. So they have the table. Our T is our x-axis, our y is our s is our y-axis, and notice they do this little dash thing. So it's a zigzag. You keep going, and this zigzag basically implies that your graph does not start at 0. So that this would be 510, 500, 514, and 518. And they kind of have them in between that. And then this would be 0, my apologies for yawning. So they do this, and then they plot their scattered points. Okay. Okay. You don't have to do it exactly how the book does it right here, guys. You can actually do it by ones. It just needs to be reasonable. That's kind of what their point is. So they do 2-point increments, but you don't have to follow their example. Okay. Plot the points. Let's look at this. Describing a rule for the function. Okay. So writing a function rule based on a graph. So you get a graph like this. Our first point, so we need to make a table out of it. So we have our x and our y. So based on that graph, we have an x of 1 and a y of 2, x of 2, y of 3, x of 3, y of 4, and x of 4, y of 5, x of 5, y of 6. Okay, so writing a rule, we have to see how much this is going up based on how much this is going. So this is going up by +1, right? This is also going up by +1, okay? So you cannot see that. It's a good point. Okay, so our y's are going up by +1, and our x is going up by +1. +1, +1, +1, +1. Same thing with our y's. Okay? Which means that they have the same slope. Okay? There you go. But there's a difference between these two. What's the difference? Well, the difference is 1. Okay? Do you see how we just subtract 1 and we can get this? 2 minus 1. Okay? Right there. Does this work? Check. Plug in 1 here. 1 plus 1, 2. That's correct. Plug in 3. 3 plus 1, 4. That's correct. Plug in 5. 5 plus 1, 6. That's correct. Okay, so it worked for all the points. Okay. Okay, in fact, that is our equation. Okay, let's look at this guy practice. And it's going down. So let's do these two. And then we'll look at that. Okay. So first rule, make a table. Okay, our first point is 0, 5. Our second point is 1, 4. Our third point is 2. I skipped over a point. Our second point is 2 and 3. Then we have 3, 2. Then we have 4, 1. Okay. So is this going up or down? This is going -1, right? As this is going +1. Okay. So our output is always a minus, okay? Negative's happening. But when do we start? When x was 0, what was y? Y was 5. So when our x is 0, we can actually kind of extrapolate that we started at 5. So let's try this. Okay, plug in a number for x. Plug in 1. 1, so -1 plus 5 is 4. That's correct. Plug in 2. -2 plus 5 is 3. Okay? So this worked. So that would be our rule. If it works, it's our rule. Okay, I want you to look at number 4. And actually, I'm going to have you type that in to our Google quiz. Okay? So I'll help you make a table. So our x and our y. And we have 1, 10, 2, 15, 3 is 20, and 4 is 25. Now, you want to look at this interval because that's actually going to be our slope. So you want to look at this interval going up because that's going to be our slope, okay? So on the quiz, I want you to try to put whatever answer you can get for this, okay? I'll lay it out so that you know that this is the example, okay? And finally, there's these 4 things. So you have a verbal way of representing an equation, a table, and a graph. Okay, that is all for 1.7. Hope you guys enjoyed. We are finished for this week. We will be viewing for the test that is on Wednesday. Goodbye, guys. I will see you shortly in class. Have a great day.